to our next section, 4.2 addition rule. I did mention the probability for equally likely outcome from the last section. Probability of equally likely outcome is mean chance of each outcome is the same. For example, if you flip a coin, chance of having head is the same as chance of having tail. Now let's look at this first example here. What is the probability of getting a sum of 7 or 11 when a pair of die is tossed? So you have two pairs of die. Let's say one is red and one is black, right? When you throw it and it lands. So you're gonna add the sum of the dot on the dice. Now it's equally likely outcome. Chance of number 1 to number 6, they're all equal. So let's say we're gonna count all the possible outcome. So I draw a diagram here. So you have, let's say I put in the coordinate. The first one is red, the second one is black, but you throw both of them at the same time. Or doesn't really, yeah, in this example I think it's the same time. So let's say it's land on the red, land on 2, and the black land on number 6. So it's going to be 2, 6 in that order. Alright, so this is all possible outcome. 1, 1, which means the red is 1, the black is 1, 1, 2, 1, 3, all the way to 1, 6. We have only up to 6 number. 2, 1, 2, 2, all the way to 2, 6. 6, 1 to 6, 6. If you count all of them, in other words, you have 6 by 6, so it's going to be 36 possible outcome. So this is total possible outcome. Now you want to find sum of 7. Sum of 7, we can have 1, 6, which means the red one is 1, the black one is 6, or the red one is 6, the black one is 1. You fit the color. 2, 5, 5, 2, 3, 4, and 4, 3. So you have 6 total possible outcome. Sum of 11, you can have 5, 6, or 6, 5. That's 2 possible outcome. So let's look at these two events. A be the sum of 7, B be the sum of 11. When you throw a pair of dice, you're gonna land either 7 or 11, not both. So they don't share. You see the circle doesn't share. So this is mean mutually exclusive. When they are mutually exclusive, it means they don't share anything, either sum of 7 or sum of 11. So from here, probability of getting sum of 7 or 11 is going to equal to probability of sum of 7, which is 6 out of 36. They're mutually exclusive, plus sum of 11, which is 2 out of 36, is 8 out of 36, which is 22.22%. So the probability of getting the sum of 7 and 11, or 11 is 22.22%. Now let's look at the next example. Hi everyone, let's go to our next example. When playing blackjack with a single deck of cards at the Stardust Casino in Las Vegas, you are dealt the first card from the top of the shuffle deck. What is the probability you get a club or an ace? Alright, so let's look at our deck of cards here. There are 52 of them. You have set of cards, which is ace to 10, Jack, King, and Queen. Jack, King, and Queen consider the face card. So basically we have 12 face card here. And then we have spades, club, and diamond. All together is 52 of them. So the probability of getting a club is right here. So you have 10 over here, Jack, King, and Queen. So 13 out of 52. Now probability of ace. Ace is right here. 1, 2, 3, and 4. So I do 4 out of 52. However, when you count the club, you count the ace already. And when you count it again this way, you count it twice. That's why I minus 1 over 52. So this is not mutually exclusive. Remember, when they're mutually exclusive, they don't share. But this part, they share. They share one card right here. They both club and 8. That's how I subtract them, and the answer will be 16 out of 52, which is about 30.8%. Alright, so let's look at the next example. Let's say someone loves to test this fast food. They order 1,118 fast food from different places, from McDonald's, Burger King, Wendy's, and Taco Bell, and do all the record and add all this. Alright, so if I add all the row here is the accurate order. Alright, this one will be inaccurate, and this one is everything from McDonald's, from Burger King, from Wendy's, and from Taco Bell. Now the first question is, if one order is selected, find the probability of getting an order that is not accurate. It's not accurate, so we look at not accurate. It's over here. So it's going to be 131 over 1,118. So, which is 0.1117 or 11.17%. So if you order from this fast food, the chance that it's not accurate would be about 11%, 11.17%, 17%, 11.17%. Repeating myself. Alright, let's look at the second example. If two orders are selected, so you have two orders, alright? Find the probability that both of them are not accurate. Now you don't have one order. This one, this is two. Two order that's not accurate. With replacement is mean that if it's already get picked, it can be picked again. That's with replacement. So the first order not accurate will be 131 out of this whole thing. Alright. Now because it's with replacement, put it back. So it can be picked again. So we're gonna have the second one will be 131 out of 118 again, because you put it back, it can be selected again. So if you do that, calculate it, it's gonna be 0.0137 or 1.37%. And it is independent, because what happened here, it doesn't affect what happened to the first order, it doesn't affect the second order, probability of the second order. Now I change slightly different. I say without replacement. Without replacement is mean whatever you pick, you will not pick it again. It cannot be picked again. So the first order, the probability of that happen will be 131 out of 1,118. Because without replacement, we cannot pick the first one that you already picked again. So you're gonna have the second order will be 130 out of 1,117 left, because the first one cannot be picked again. And if you calculate this, you're gonna have about 1.36%. And this is dependent because the second order depend on the first, right? So this is dependent. The first case is independent. So we finished 4.2. I'll see you next time. Bye.